So it seems like many flat earthers now believing 10th man in his claim that you cannot draw a circle of equal altitude on a sphere like this one, or a physical sphere if you have a globe model. So today I'm not going only to show that you can do it, but I'll show an actual uh, or simulated example for celestial navigation using the nautical almanac and the globe model, or in this case, for simplicity or to make it easy for me, I'll just use Google Earth because it's much accurate. So how do we draw a circle of equal altitude, and that circle of you can call it circle of range around the geographical position of a star? So let's start first thing by having a place. Let's say that this is your location, and then you look to a star. When you look to a star with an angle, that star is somewhere perpendicular on the surface of the earth, somewhere. So this is the GP of the star, and this is your location, and the difference between here and here is just difference in latitude. In this example, both the GP and the ship are on the same longitude. So you'll have this is the horizon, this is the elevation angle to the star. Now we have an angle here. This angle is also the elevation angle, or equal to the elevation angle. So what you do is you just bring a metal compass, you put the pen on the GP, you made sure it is in this a little bit awkward sitting, that you have this side perpendicular to the GP, and then you'll need a little bit longer arm to get the pencil on the earth. In this position it's almost the tangent, it is the tangent. So at the tangent point you start moving your compass like this. Now, since I don't have a globe model, or my small one is very rigged, so I'm gonna do it with Google Earth. And the way to do it is, I know that this angle is the latitude difference. Let me remove this thing. Yeah. So we have elevation angle here, and this is equal to this one, and this one is right angle because it's between a line going to the center of the earth and the horizon. So this is a right angle. This is the latitude, the difference in latitude between the GP of the star and your position. So all I need is to know the difference, this latitude difference. I just 90 minus the elevation angle, and then I extend from here to here. This is the upper rim or the lower rim of the circle, north and southwise. Here is the simulated example. I'm using stellarium, and I'll just select a random point on the map, and you can see the coordinates change. And I'll use a specific and fixed date and time. I choose 13 of October, 9 p.m. I go to the nautical almanac and make sure that it is set to 13 October. Then I get the time, and you see here the time has GHA for Aries. And then I'll pick my 3 stars. Each star I will just get the elevation angle. So this is the first star. I'll get the elevation angle. The GP of the star is already calculated in that spreadsheet. I just copy the elevation angle and put it, and then also I should copy the the sidereal hour angle, or SHA, of the star. So I did that. First I put the elevation angle as you saw, and then I'll get the star. That's the sidereal hour angle, how much it is shifted from Aries, the reference star. I put the angle here, and you can see that the spreadsheet I made, it just give you the GP, or the latitude of the star. And I'll do this with all 3 stars. Now I copy the upper rim position for the circle of equal altitude for that star. So that's the upper rim. That's the highest point of latitude from the GP of the star. Then I plot the star itself. And I draw a circle from GP of the star and make sure that the upper rim, or the lower rim in some cases, touches the point that I already calculated previously. So that's my first circle. So now my 3 circles of altitude are complete, and the intersection is usually a triangle of error, this triangle. So where's my location already? So I'll just copy it from Stellarium. That's where the observations were done. And then my location would be in the center of, well, let me put this is the location already. The calculated location would be in the center of the triangle. It should be 1/3 closer to the base. Now, looking at this now, this is less than 1/3, so I'm giving myself more accuracy than I should have had. So I'm off by around 2, say 3, or even 4 nautical miles. I think that's accurate enough, bearing in mind that I ignored some fractions and some seconds in the measurements of altitude. So now you've seen how to use the nautical almanac and the stars to find your location. Now there's incoming challenge for 10th man or any flat earther. It's not going to be as hard as this. It's going to be ridiculously easy, but I challenge the flat earthers to do it. Now let's see. Hope to see you soon, 20th of October.